Nguyen. She's from the Department of Mathematics and Statistics, Youngstown State University. And then the title of her talk is Hidden Markov Model and its Applications. So please.
Thank you so much for inviting me for this seminar. It was very impressed that you can organize this kind of seminar in the department. Okay, so my talk is about applied mathematics, not the pure math like most of the talk in the semester. So I hope that you will see like something different from a lot of things that you are doing. So this is the model that I'm working in like for a very long time since 2012 when I worked for a company in Florida in summer internship. So I worked with this model for 2 summer internship in this company, and I applied this model to predict some stock price. And I wrote the code to run the models, and I really like it. That's why I'm working on it for like until now, and I think for a few more years. So this is the outline of my talk today. I will introduce about this model and some application in some field, and introduce my work. And I will present one of my work using the hidden Markov model in global stock selections, and present some results. You can stop me anytime if you have any questions. So first, I would like to give you a very simple example of hidden Markov model, how it applies in the real life. So suppose that you observe the weather. You will see some like common patterns like rainy days, cloudy days, sunny days, and in Alabama maybe like storming days. So if you observe this sequence, then you may want to predict what will happen tomorrow. What is the probability of tomorrow when you will have sunny day, or what is the temperature next day, something like this. Or even you can predict some coming severe weather in the areas. So in order to do that, using the hidden Markov model, you need to have the observation sequence. So for example, you observe in 1 week that you see like sunny, rainy, cloudy, and rainy. Example like this. And you need to make the assumption that the probability of getting the sunny, cloudy, or rainy, that's equals 1/3 for each of these events. And then you will use the hidden Markov model. It's based on the Markov chains probabilities. Then you can generate the transition probability, this one. So for example, when you input this observation and input the initial probability for the first day, then you will have the transition probabilities. This is the constant transition probability. The probability is that if today rain and tomorrow rain is 0.2, for example. Today rain, tomorrow cloudy is 0.3, for example. So you have this one is 3×3 matrix. And then after you have this one, you can calculate the probability of observe the sequence of events like this for the weather. So if we apply, because this model like follows the Markov chains process, that means it's memory list. That means the probability of tomorrow happen only depend on the today, right? So we can use this property to calculate the probability, the condition probabilities by conditional probabilities, and then you have the probability of you observe a sequence of events like the weather for 1 week, like 5 days, is like this is 0.0084. So this is simple example of what we can use the hidden Markov model for the simple weather predicts. Now, I go more detail about the notation of the model. And first one is the observation data we denote by OT. So the observation right here can be like multiple series. For example, if you predict weather, you may consider like the temperature, the wind speeds, the rainfall, and something. So you have multiple series for the inputs. And then we assume that like below the observation, behind the observation data, you will have the hidden state. So the hidden state we denote by S. So this one is the one that we assume. So for example, I assume that like one day I have only 3 possible for the weather, sunny, rainy, or cloudy. Then I have the number of states is N. Then I have the hidden state sequence. That means after I define the hidden states, then I can use the model to predict the state sequence Q. And I can calculate the transition matrix A. And then I have the observation symbol per state V also. And I have the observation probabilities matrix B. And I have the initial probability of being in the state I in the first time is the P. So in the picture right here, you will see, so this is the transition matrix A. After you change the model, you will have this one. And you will have the observation probabilities matrix B. So suppose that you find that, okay, behind the observation OT, this is the state S1, then you can, based on the observation probabilities matrix, you can calculate the probability of getting the OTs given the S1. So the parameter for the model is the components of the matrix A, the probabilities, the observation probabilities B, the matrix B, and the initial probability P. So P is the vectors, A and B as matrix. So A is the matrix, N and N depend on how many states that you define, and B too. So this is the picture show you how we can use the hidden Markov model to solve the real life problem. So suppose that I have the observation data right here. Maybe like it's multiple observation data series, and I use the hidden Markov model. I change this model using the historical data. Then I can find the transition matrix. After that, I find the hidden state. So for example, like O1 corresponding for the S2, O2 for the S1, state S1, and something like this. So I have matching the observation O to the hidden state S. So after I have this S and the transition matrix A and B, and then I can calculate the probability of observation in the futures. So this is the process of using the hidden Markov model. So there's 3 problems that we can use the hidden Markov model to do. The first one is if I have the model already. So I have the observation data, and I have all the parameters for the model, the transition matrix, the observation probability matrix, and the initial probabilities vectors. Then I can calculate the probability of observation. So this one is the example at the beginning. I can calculate the probability of in 5 days, I will have the sequence of the weather events. So in order to do that, we have some algorithms to calculate the forwards or backwards algorithms. And the second problem is if I already have the models, that means I have all the parameters for the model and I have the observation, I can find the hidden state. The hidden state is this sequence right here, corresponding sequence right here. So how to find the hidden states? We will have the Viterbyte algorithm. This algorithm working like we will like assume that okay, hidden state is this sequence, and then we calculate the probability, and we want to maximize the probability of the observation. So when you reach the maximized level that you set up, you will have the hidden state. And the last one is the hardest one. Like when we have only the observation data, using the hidden Markov model, you find the parameter for the model. That means you find the model. And then this problem, we can use the Bauer algorithm. This algorithm is based on the like in the, we have the many algorithms to change the parameter for the model based on the Lagrange theorem. So if you continue to find the minimum or maximum of the function, you can take the derivative of the function, right? And if the function is not like closed form function, then you can use the methods of approximate the derivative of the function. So in this step, we will use many like mathematics program to estimate the parameters. So some histories of the hidden Markov model. So this model was introduced like a long time ago, before I was born. And in 2009, 1970s, this model, like the people can like change the model. That means first they introduce the model, but they don't know how to find the parameter for the model. And like 4 years later, they know how to find the parameter for the models. And in 1983, they can find the parameter for the model using the multiple independent observation series. But in 2000s, they can change the models using the multiple observation without the assumption that we need to have the independent observation. So this model still like continues to improve by times. That's why I really like this one. And this one have many applications in real life. So the first application of this model is they apply this model for speech recognition. So when they hear the sound of they can recognize the words behind this sound. And they have applied this model for bioinformatics and finance and weather forecast. So when I work with this model in my internship, I need to write the code to predict the stock price and the option price of some stock. It's based on the previous work from the other researchers. And now I expand my work to weather forecast. And in futures, I want to apply this model in bio. This area requires a lot of background. That is not my background, so this is my dream, but I don't know if I can do it or not. So I apply this model to predict stock price, mortgage-backed securities, and economic regime, predict weather apply in stock tradings. And recently, we are working with collaborators in Indians to apply this model to predict the global bonds price or the reaction of the global bond price to the COVID-19 pandemic. Okay, so this is the example of our work when we apply the model to trace the stock in the global stock trading. So that means we use all countries' world index. Okay, so the all country world index, including like 23 developed markets and 24 emerging market countries. And in 2017, it consists of about 2,490 continents or stocks. So these numbers change every month or even every day, because every day the stock markets will have some register and some out. So and it converts cover about 85% of the global investable equities opportunity set. So this is why we want to set up our trading in this very large markets. We apply the hidden Markov model for to trade in the U.S. markets to pick up the stock in the SP 500 already. So this one we expand to the all country world index. Okay, so here is the overview of the all country world index. So we have in US is a big market in this set, so it's about 25%. The stock in the US contribute to the all country world index, and you see the other country too. So ASEAN about 20%. And there are some markets capped by the all world index right here too. So you see in these categories, the US is 43.74% also. So that is very large in the US markets. So if we define by the sectors, we have many sectors in the all world countries index. So you see the financial sector is 17.57%. It's the largest portion of this one. So we have the different ones. So if in the future, if you interest in stock trading, you may see the information is helpful for you. Okay, so now how we use a hidden Markov model in stock trading. So first, because this is a global market, so we need to consider the global economics indicators, because the stock price derived by different economics indicators. So we need to choose some economic indicators, put this one as an input for the hidden Markov model. And then we will find the regimes of the economics indicators. The regime, what is the regimes? The regimes, that means the state, the hidden states behind the economics indicator. For example, if you look at the inflation rates or the interest rates, you can see, okay, at this time, pandemic time, the interest rate is really low. And some people even predict it may be negative. So the hidden Markov model will detect the hidden state behind that. It may be in the very low state and the high state, for example. And then based on these states that we use the hidden Markov model to find, then we can analyze the performance of the stock based on the hidden of the state of the global economics indicators. And then we can score the stock. So we have 2,500 stock, and you need to score every stock based on the factor of the stock, and then we will pick up 10% of the stock that have the highest score, and then we put this 10% in our portfolio, and we do it every month to refresh the portfolio to trade. So in order to do that, we need to consider some stock indicators. So there are some stock indicators, for example, free cash flow over the enterprise value, and the earning price per share, the price, and sale enterprise long-term sale growth. So if you interest, you can find the definition of these terms in many finance papers. Okay, Yahoo Finance is a good one. And then we need to define the global economics indicators. So global economic indicator, we consider the inflation, the production, the sentiments, the market, the debt, the inflation, manufacturing. So this is the title of all the 6 global economic indicators. So these 6 global economic indicator will be the input for the hidden Markov model. Okay, so this is the picture so used when we scale the global economic indicators and we plot the data. So you can see that the data like up and down. The work of the hidden Markov model is this model needs to look at the patterns of the movement right here to define the states behind each of these indicators. So this is an example of the results that we use the hidden Markov model to find the hidden states behind the this data. So this is a statement. So this one, for example, when you see when the data going down right here, we have this one is belong to the state. The stated one is the regime 1. So this is the state 1 or regime 1. Regime 1 right here is regime 1. So you see that the model detect the regimes of the observation. So this is the first step. So this is for the other indicators, economic indicator too. So we only use the 2 regimes. That means we only like use the definition of the bull and bear market. We can use more than 2 regimes. For example, you have bull and bear market and the stable market. So you have 3. So it depends on how many do you want to. You can set up the model, and for set up the probabilities, the observation probabilities, you can choose the function for the observation probabilities. So the function can be like the mixed normal distribution or the exponential distribution or the any distribution that you think is fit with the data. So you can test the different distribution to match the model. But in our school, we use a normal distribution for each regime. For example, in the regime 1 right here, that means we assume that the data will come from a normal distribution with the means and standard deviation detected by the model. For example, when we run the model and then we define the mean and standard deviation of the normal distribution for the 2 regime or the 2 normal distribution. So for the regime 1 is negative, the mean is negative 10.30, and the sigma, the standard deviation is 13.21. That means all the data in this shaded right here is come from the normal distribution with the means is this number and standard deviation is this number. Like hypothesis, like this is the assumption. So we need to have assumption and the model will give you the results. Okay, so after we find the regime of 6 economics indicators, then we will analyze each stock factors, and then we assign the stock factors a weighted. For example, like if you look at the Apple stock, you may look at the 5%, for example. So or earning per share. This is 1 factor. If you only look at 1 factor, then it may be not the good one for you to decide that, okay, this is a good time to buy or sell. So you may need to look at the many other factors. So you see that we look at the 1, 2, 3, 4, 5 factors. So for these 5 factors, how can we like calculate the composite score for each stock? We need to define the weighted for each factor. So for example, this factor, we need to define the weighted is about like 0.3. This one is maybe like 0.1. This one is 0.2, and the sum must be 1, right? So based on the performance of the stock in the regime of the economics indicators, then we can define the weighted grade for the 5 different stock factor right here. So after we define the weighted, then we can, based on this one is the ones that you can have from the company. So earning over price rate, earning over price, this one you can have from the company. And then you put the weighted that you calculate, then you have the score for the stock. So we scale to have score about like from 0 to 100 for each stock. So the normal way that people or many financial companies did is they assign equal weighted. That means they don't need to use any model to predict the weighted for each factor. Just take this one is 0.2, 0.2, 0.2, 0.2 for each of them. Or if they choose like 10 factors, then they just assign equal weight like 0.1 for each factor, for example. And then they calculate the score, and then they rank the stock and then pick up the stocks that have the highest score. So the way that we did is we use a hidden Markov model to determine the weighted for each factors to see if it's performs the equal weighted that people use in the financial industries. So after we assign the weighted for each factors, and then we score each stock. We rank them from 0 to 100, and we only pick up 10% of the stocks that have the highest score, and form the portfolio from 2005 to 2017. So our performance is the red line right here. And the blue one is the performance of the all world index. That means the composite of 2,500 stock in the all world index stock. So you see that like our performance is like always higher than the all world index stock. And at the end, so we assume that at the beginning, we invest about $100 in 2005, and in 2017, we have 316. And if we only like invest in the all world index, that means the whole portfolios. The earning is even have the ending is about like 170. So you see that when we use a hidden Markov model in tradings, you have higher returns. Now, I said before, like if we only look at one factors, one stock factor, for example, if you only look at the sale over the enterprise of the company, and you score the stock like all 2,500 stock, and then choose the stocks that have highest score, then it performed well. If you look at the factor, this factor is for sale enterprise factors, and with 100 2005 in 2017, you have about like 280. It's not bad. Compare with this one is the all world index right here is 170 as before, right? So this one, if you only like based on one factor, don't need to use a hidden Markov model, you have good return, better return than this one too. However, if you look at the other factor of the stock, for example, like the earning per share, growth factors, you almost have identical returns with the all country world index. So you see that's almost the same. So you see like based on X factor, you have different performance if you based on these. And this one is the other factor, the equal weight factor. So the equal weight factor is the methods that many financial company use. That means they just choose the number of factor and assign the equal weight, and then they score the stock, and then they choose the stock that perform well based on the score. And if we do like this, you see that is almost identical at the end with the over index, because this one is a little bit higher only. This one is higher in here, but at the end it's almost the same. So the conclusion is using the hidden Markov model to analyze the performance of stock based on the economics indicators to assign weighted for each stock factors will give you the better return for trading compared to the equal weighted that many people use. So this is the end of my talk today. I hope that it's not too short or too long. Thank you.
Thank you very much for your interesting talk. Do you have any questions for our speaker?
This is different from the areas that you are working on, right?
No, it's fine. But I'm interested in the inside of the algorithm. Like at the beginning, you said your example, and you said about the matrix of 3 by 3. And how, but you didn't show any algorithm, like how that works with matrices. And this picture is really nice. So it seems like you use the algorithm to recover some stage, right?
Yeah.
Is that correct?
Yeah.
So I think do you have any algorithm to show?
Yeah, I have algorithm in my paper, but I don't put the algorithm here because I don't think it's like when you look at the algorithm, it's all the formula and the notations. It's the name of the algorithm is right here.
Okay.
Yeah. So this algorithm, like for example, the I talked before, like in the Bauwens algorithm, we use many different mathematical formula and function in this algorithm. For example, you need to use the optimization methods. So in optimization methods, you need to use there's like many different methods to find the maximum or minimum of a function. So it's in hidden Markov model, the purpose of getting the lambda is you have the observation data. For example, in this example I show you, this is very small observation data of the weather. If you have the largest data set, and the purpose is you want to maximize the probability of observation of these data sets. So in order to maximize this one, we will need to use some optimization methods to use to find the maximizer of the function. And it depends on the function that you choose to. So the function for the distribution you define from the hidden state to the observation is a factor to determine if the algorithm will run faster or slow, or even is not converse. So you can see that with only like 3 state and 5 observation right here, we have the probability 0.0084. It's really small. So if you have more observations, the probability is really, really, really small. So behind this model, there's many other techniques that we need to use, scaling technique to avoid too small number, because you know that the computers will not accept very small numbers or very big number. So we need to scale to make the computer work for you. So yeah, it's really complicated. So I only introduce some notation and thing. I don't introduce all the algorithm right here.
Okay, so the matrix is not full in the sense that you mix some entries, right, in the matrix.
The matrix, we have two matrices. The transition matrix, that means the transition from this one to this one, this one to this one.
So we know those matrices, right?
No.
Okay, so we don't know those matrices. So that means we might consider like we mix some entries, and this algorithm helps you to recover the matrix and the states. That's what I understand.
Right. Yeah.
It sounds very interesting because like I remember some problems like even in big data they also do like that. They work with matrices with losing some entries. They don't know all entries of the matrix, but they still want to evaluate the rank or some information from that matrix. That's why I want to see how the algorithm works. So.
Yeah, if you want, I can open my other talk to show you the algorithm. So it's because you said that like this talk is like for like most of the people that don't work in finance area, so I don't show the formulas.
Okay, that's fine. Okay. Do you have anything else for our speaker?
May I ask a question?
Yes, please.
Okay, so could you please turn to the weather model you present the page?
At the beginning?
Yeah, this model. I asked a general question about the model building, like which factors will you be able to use in the model? For example, like in these weather models, we have assumption that like we just looking at the matrix of transition probability from like sunny to the cloudy and so on. But if we have, let's say, if the past few days they are rainy but today is sunny, it probably has a higher probability, right? Tomorrow will be also rainy rather than sunny, right? So comparing with no prior knowledge. So my question is that in general, what kind of the factors to put it in the this Markov model, and or like why do we assume that they are additive, or we can apply the this Markov chain model?
Okay, so what we are doing with the hidden Markov model for weather predictions is right now we apply to predict the temperatures. So for example, when you have the temperature in one area, in the like city, for example, right? So you have like the temperature from 10 years ago daily, then you put this input to the hidden Markov model, and we assume that you have the three states, like rainy, cloudy, or sunny, based on the temperatures.
Okay.
So after I run the models, the model will give me the transition matrix, something like this.
Yes.
Yeah, and the hidden state, like the sequence of the rainy, cloudy, sunny, after behind the observation, the temperature, and based on these transition metric and the probability. So the first assumption that you assume like you have the probability of getting the sunny in the at the beginning of the sequence is 1/3. You can assume it's 0 for the sunny. Whatever, it doesn't matter, because this one is only the initial probability to put in the model. So the model will maximize the probability of the observation of the sequence of the temperature to give you the final, the probability P.
Okay.
And then the transition matrix, and then the observation matrix B also.
So do you use the machine learning to like figure out which factors will be more important in contributing these temperatures?
This is a very good question. Yes, we need to use a machine learning, like maybe the ANN, to determine like which factor is the best affect to the weather if I want to predict weather. So in my application to the trading, so you see that like we have many different economics indicator. We need to see like which one is have the highest weight to the performance of the stock. So we're doing like this too. But the suggestion is like we may use other model to find the best factor first, and then using the hidden Markov model later.
Okay, thank you.
Thank you. Hello? I cannot hear you.
You have to mute.
Okay. So my question is a little bit, personal, but because you talk about how you apply the model to stock markets, right? And you analyze when you need to buy, when you need to sell shares. Yeah, I was interested in this a little bit, but because I know some brokers, they already have very good tools to analyze those, the price, how about the market looks like. So did you apply your model to your personal, I would say?
Yeah, for my personal trading, I apply this model too. I have many people ask me when I present my work in conference about like, did I apply it? Yes, I did apply it. When I apply, I focus on some stocks that I like, and then I use a hidden Markov model to predict the stock price. So it's not always that I can predict it's like very like correctly 100%, but it's okay for me to make the trading decision and make a good earning. And also the companies that I work for my summer internship is a financial manager company. This company will manage the fund for individuals and for the other company too. For example, the school have some money set aside and want to invest. These companies, they will have the school to invest, and they will charge a fee. So that is the reason why they want me to work in this model in stock, in stock trading, and they apply it. And the person that I collaborate with is the person that work for the company, and the company like give advisor and tradings for the individual and companies in long term. So you can see like I present like when we use this one for the global stock trading, you look at the long term, like from 2005 to 2017, for example. So we adjust the portfolio like monthly. Yeah, so this is the real life application, not only the theoretical one. But in the trading, you see like X company will have many different methods, and they will use like they will balance out, and X person have different methods to trade too.
Yeah. All right. Yeah. Thank you very much for your interesting talk. So and thank you everyone for being here today. So next week we have talk delivered by Dr. Horn from Auburn University, but a little bit earlier, so from 8 a.m. to 9 a.m. Yeah, so thank you again and look forward to seeing you next week.
Okay, thank you.